Hello and welcome back. So on the workbench today, we've still got the Solectria brushed DC motor controller. It's got problems. Remember earlier in the last video we were looking for the serial number. It is actually serial number 1. The serial number is written on the back side of the circuit board here. Yeah, it's a little, it's very prototypish. Like we've got a bank of MOSFETs here, and then there's another bank below it. It's a 2-quadrant controller, no reverse. So the first bank handles acceleration, and then the bank underneath does the regenerative braking. You can kind of see there's a bunch of big capacitors underneath, and we even got a little current sensor over here. So yeah, it's very prototypish. It's definitely been worked on before. You can see that like this diode has been replaced versus that one and that one. It's like this whole bank. These are the opto-isolators there. These are the drivers that actually run the PWM signal to this bank or this bank. So the circuit's like in through here is the drivers. Yeah, I guess we could go through backwards. And all of this is what generates the PWM value. The signals coming in from the pots come in through here. They go through these chips. Might be, I don't remember. No, it's definitely this one. They go into this chip and get conditioned and turned into a PWM signal, which then goes to these guys. And then the rest is like current limiting and yeah, so it would read the current sensor and then current limit based on that. And then everything else over here is power supply. So this is a switch mode, high voltage switch mode power supply chip, which has gone completely obsolete. It has a problem. That's why nothing powers up. But it takes the 36 volts in, and then it turns on and off this MOSFET. Goes to this transformer, which generates 3 supplies, 15 volt intermediate voltage for the 7812 linear regulator, which powers pretty much everything, and then the 2 isolated supplies to run the essentially the gate drivers for the MOSFETs. And yeah, that's all that's going on. Unfortunately, this thing's got issues. Like so right now I've got it plugged in. We've got 36 volts on it. I've got my supply in series, same as last time. And if I take my meter here, so we're just gonna probe. You can see I got my 36 volts coming in here, or 35.6 volts coming in, and it goes to here. And then if we come over here, this should be 15 out, and we got nothing. Here, actually, let me move this. Actually, we'll just put that like right. Will that stay there? Yeah, that'll stay there. Okay, that makes it a lot easier to probe. So yeah, we should be having 15 volts right here, and it's obviously not running. The output is obviously 0 too, because we don't have the 15 for it to regulate down to 12. I'd show you the other supplies too, but they're on the back side of these caps, and it's a lot harder to get to. Excuse me, I am starting to get a cold because it's that time of year. But here's what's interesting. I can jump start it. So we're going to hook on here. So essentially that switch mode chip, which I just covered up, the one down in there. So what it does, it's got a little essentially standby supply which gets itself going, and then once it's up and running, it uses the main supply to power itself, and then it shuts down that standby supply. It's built into the chip. That part's dead. So I can show that because I can jump start it. So this isn't live. This doesn't have any voltage on it yet. I'll go ahead and plug this into the output. So what we're going to do is actually just put 12 volts on the output. So if I were to go like that, you'll see there's nothing on it. But we're going to jump start it. So I'm going to come over here to my supply. I've got my other, so we switch over there and we got it set to 12 volts. We're just going to momentarily click it on and click it off. And that's it. And if I go ahead and take off this, you will now see we got 12 volts. And we have the 15 volts intermediary supply. So now the switch mode supply is running, so it's up and running. But notice I have no other LEDs, so it's still all hooked up. We got the motor. I can go and give it throttle, regen, nothing happens. So once I discovered that, start looking around. It's like, well, let's see what the outputs were, what the pots were doing. So I followed the wires over. They come in through here, and I'm checking. We've got 12 volts and ground. So see how there's 3 pins on each side. There's 6 pins, but then 3 on each side. So it's 12 volts signal ground, 12 volts signal ground. I got the 12 volts. I got the ground. And the signal was not right. Like, it's not going between 0 and 12 volts like you would expect when you turn the pot. So I went over to check U, which is this one, U1, and it's really simple. It comes in on, like I said, these are 2 mirror images. One handles the acceleration, one handles the regen. And there's a 100K resistor pull down, another 100K resistor pull down. I measured those, and they're like 100 ohms. And the other one's like 1K, and it's like, that doesn't make any sense at all. Because it's literally just, the signal comes in through there. That's just a pull down to make sure that if you don't have any pots hooked up, it pulls it down to ground. But there were also these capacitors in the 0.1 capacitors were in parallel with that, just as to make a low pass filter. And I had to replace them. The legs were broken. You see that? Both of them, both input capacitors, 0.1 caps, had blown up. How does that even happen? It's like a pot interface. So after I replace those, we now get 0 to 12 volts. Like I can put the probe on there, vary the pot, and you'll see it go from 0 to 12 now since replacing these capacitors. But then the output of it goes into this, which is just voltage follower. It's a bunch of op amps configures a voltage follower, and I get nothing out of it. It's always 0. So this chip's dead. And then I started looking around, and it's like, you know what? This guy, is it this one? This one is a NAND chip. Yeah, it's a 4090. What is that? 4093? Yeah, 4093, which is just a Schmidt trigger NAND gate. But they're configured as input or inverters. And I can see 2 lows going in and a low is coming out. So I think every chip on here is dead. I think somebody's in here, somebody's already worked on it. And I'm wondering if they actually, I mean, if you look, it does look like it's been replaced, voltage regulator. I think at some point, this supply, because everything looks like it's been replaced. Like a lot of stuff looks like somebody's been in here working on it. And it looks like, I think what happened is this guy failed in such a way that or somebody hooked it backwards. I don't know. But somehow we had a failure of the main switch mode supply. And maybe it let 36 volts go into this guy, which then eventually failed and then passed it along. I can't really tell because it's been worked on before, but I mean, like, some of these things look like they've been burned. Like, look at this resistor here, right? That's a 100 ohm resistor. I know that because I can compare it to its mirror image over here. And that guy, it still measures 100 ohms, but it's been really, really hot, right? So, I don't know. I gotta ask the customer if he really wants it fixed, because it's looking like every chip needs to be replaced. And then I'm really worried about all these 0.1s in here. The fact that I had 2 of them on non-critical, non-switching, just low-pass filtering pot, unless somebody hooked something they weren't supposed to this and just popped it. That doesn't make any sense. But yeah, plus the switch mode supply is not even working anymore. You have to jump start it. There's something wrong with this chip internally because it takes care of that. So it's broke. And somebody's worked on it because there's a cut trace here, but then it's been reconnected, and there's a whole nother thing on the back, but it's bypassed by this jumper. And I tried taking that out thinking maybe that was the jump start circuit, but it didn't. It doesn't work at all with that missing. So I jumped it back in, or connected it back up. I don't know. I've spent a bunch of time on this, and it's just, I don't know. I think it might be, you can get a cheaper one somewhere else. Honestly, I mean, this thing was built copyright 1989. It's almost 2019, so this is 30 years old. So it's quite possible that these capacitors are actually just dying because of old age. Like, they're cracked just from, just being old, which means there's a lot of them in there that all have to be replaced. Like, if I were to redo this to get it up and running, I'm probably going to replace like all the chips, because I'm pretty sure that they've all been exposed to more than their rated voltage, and that's what killed them. I would definitely want to replace all the electrolytics, because they're probably all original. And then, yeah, and then it's going through and maybe even replacing every one of the 0.1s. All these yellow 0.1 capacitors, I think, are might be just bad from old age. But yeah, I don't know. That's kind of where I'm at. So I'll email the customer and see what they say, and if we want to continue it, I've got another motor controller to fix. It's a different one, but we'll throw that on the bench next while waiting. Anyways, yeah, long video. Thanks for watching. Bye.